So therefore we have work done is equal to pressure times change in volume. And of course, to convert unit joule, we use 101.3 joule, which is equivalent to 180 liter. Okay. So now the next thing is enthalpy. What is enthalpy? So after this, we are going to take some examples and we'll solve problem. So what is enthalpy? The enthalpy, if a process placed at constant pressure, so as the majority of the process we study do, and the only work done is this pressure volume work. So we can account for heat flow during the process by measuring the enthalpy of the system. So ladies and gentlemen, in a simple way, when we said enthalpy, it means is the heat content of the system. The amount of heat in a system is what we call enthalpy. The amount of heat. For example, if you calculate the amount of heat that you have in your room, is what we call enthalpy. So enthalpy is the internal energy plus the product of pressure and volume. So this is a formula for calculating enthalpy. So we have this enthalpy, which is delta H, which is H, is the something as enthalpy is equal to internal energy plus pressure times volume. Okay, so it's a product of pressure and volume. So that is enthalpy. So then what of enthalpy change? So when the system change at constant pressure, so when the system change at constant pressure, then the enthalpy will now also become changed. So it will now going to be a change in enthalpy. And of course, when we said a change in enthalpy, it can be something like this. So enthalpy change, which is delta H, can be enthalpy of product minus enthalpy of reactants. Or it can be final, that is enthalpy of final minus enthalpy of initial. So that is change in enthalpy. And at the same time, it can also be change in internal energy. So it can be change in enthalpy is equal to change in internal energy plus change in volume times pressure, or change in pressure times volume. So this can be our enthalpy change. So therefore, it can be written as this, as the change in enthalpy, that delta H is equal to delta E plus P delta V, because the pressure is constant. So since the pressure is constant, there is no need to write it a change in a form of change in pressure. So since if you can remember, delta E is equal to Q plus W, and then W is equal to minus P delta V. So can we change this? Yes, we can do substitution. So it can be now delta H is equal to delta E plus P delta W. So what is delta E? First, delta E from this, we talk about this, so delta E is equal to Q plus W. So that is why we'll now replace delta E with Q plus W. And then we have our W is equal to minus P delta V. So that is why P delta V is also replaced with W. So that is why we have delta H is equal to Q plus V minus W. And that is the reason why we said enthalpy is the something as heat energy, but at constant volume. So at constant pressure. So at constant pressure, get this condition. At constant pressure, the change in enthalpy is the same thing as heat, that is Q. So that is why we call enthalpy as the heat content of the system. That is the amount of heat that is present in a system is what we call enthalpy. Okay? So at constant pressure, the change in enthalpy is the heat gain or loss. So it can be heat gain or heat lost. So enthalpy of a reaction. So assuming now we have, so the change in enthalpy, that is delta H, is the enthalpy of the product minus the enthalpy of the reactant. We have already shown this. So you see, this is our reactant. We have carbon 4 oxides. We have we have methane bond in the presence of oxygen. So it's a combustion. So carbon dioxide, his carbon dioxide and water are produced when methane react with oxygen. And of course, the change in enthalpy of the products, that is delta H2, is 890 Kelvin. And of course, delta H1 is minus 890 Kelvin. So that is the enthalpy of reaction. So this quantity, that is delta H, is called the enthalpy of reaction or the heat of reaction. So now the truth about enthalpy. So enthalpy is an extensive property. So we have what we call intensive properties and extensive property. So enthalpy is an extensive property. So delta H, that is change in enthalpy for a reaction in the forward direction, is equal in size but opposite in size to delta H for a reverse. So it means that if it is moving in forward direction and the backward direction, all the values are the same, but they are opposite. One will be positive and one will be negative. And that is why, if you remember from the previous slide, we shown the enthalpy of the reactions of methane with oxygen for the forward reaction is plus 890 Kelvin, joule. And then for the backward reaction is minus 890. So a change in enthalpy for a reaction depends on a state of a product and the state of reactant. So that is to tell you that a change in enthalpy is a state function because it only depends on the initial state of the reactant and the final state of the product. So we now have example here. Or maybe before we start with this, I think let us start with the first formula where we introduce those ones. Then let's look at the calculation of internal energy, enthalpy, entropy, and other things. So we should rejoin the meeting again. Let's rejoin the meeting again, or maybe you can just wait.